So let's use the Taylor template to come up with the Taylor series, including the first four terms of the function f of x equals e to the x, and we're going to center this at x equals 2. All right. So we know what our overall template is. We have to find the function's value at the center, which is 2. We also need the derivative of the function's value at 2, the second derivative, so on and so forth. All right, so we'll just get those down for starters. Now, we need to find our derivative. And thankfully, we have a function which is rather nice to find the derivative of. What is the derivative of e to the x? Exactly, it's e to the x. So well, let's put this over here. I stole the board there. So we got f prime of x is equal to e to the x, and f double prime of x, well, that also happens to be e to the x, and f triple prime of x also happens to be e to the x. So as we are plugging in 2, well, we're getting the same value every single time, which is e squared. So each of these values ends up being e squared. And now that we have those values, we have the ability to create the coefficients of each of the terms of our Taylor series. All right. So what's happening? Well, we start with f of 2. So we're going to have, well, let's just call this our series t of x. All right. So we have f of 2, which is e squared. And now we add to that the derivative of e, evaluated at 2, times the x minus 2 binomial. All right. So plus e squared, and then x minus 2. And yes, technically that's over 1 factorial. All right, get rid of these now. We know what our derivatives are. And now we go to our quadratic term. So it's going to be plus, and then we have our e squared. But this time we have to divide it by 2 factorial. And we can just write the 2. Right? And we have x minus 2 squared. And we're asked for the first 4 terms. We have 1, 2, 3. We need a 4th term. So that will be the third derivative of f evaluated at 2, which once again is e squared. So we have e squared. This time it's over 3 factorial, or 6, and then x minus 2 cubed. All right, and then we'll actually move over here, plus, dot, 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 plus. And now we need our general term. So with the general term, we know that we have e squared in the numerator, because it's always there, and then we're dividing it by 1 factorial, and 2 factorial, and 6, which happens to be 3 factorial. So we're dividing it by n factorial, and we're multiplying it by x minus 2 to the nth power. All right, so there's our general term of our sequence as we move forward. All right, so there's our answer for that example.